Hello, and thank you for visiting Reliability Engineering Solutions and Quickcheck loose fastener indicators. So let's talk about fasteners. Odds are that you use them. Odds are that they fail you. Odds are that costs you money. And odds are that makes you mad. You want to talk about it? Fastener failures. It's been estimated that approximately 70% of all mechanical failures occur due to fastener failure. That's 70% of all mechanical failures. Fastener failure could be self-loosening, tensile overload, shear overload, chemical attack, or fatigue. So what exactly is a fastener? Well, a threaded fastener is simply a long inclined plane that's curled around a central axis. The threaded fastener is used to secure two things to each other. The fastener holds these things together by utilizing a clamping force, which is commonly called a preload, that's applied by the user, and it's usually measured in units of torque. The preload consists, at least in part, of an axial stretch within the elastic range of the threaded fastener material. The preload can be thought of as a stored spring-like force that is constantly trying to push the nut back up the inclined plane, which would result in a loosening of the joint. Throw in some extra vibration, unusual stresses, or maybe just inadequate torquing, and all those add to the potential for the joint to loosen. Friction in various forms is the only force keeping the fastener in check. There's a variety of sources of friction that are utilized to resist the self-loosening. This friction attempts to lock the fastener in position. Let's take a look. Some typical methods of locking. As we said, just plain friction is one method. There's also nylon type nuts, there's locking compounds, a variety of form of locking washers, and tie wires. And these methods work perfectly every single time. Except back in the real world, where 70% of mechanical failures are due to fasteners.